Hi, my name is Andrea Kawabata, and I work for the University of Hawaii's College of Tropical Agriculture and Human Resources Cooperative Extension Service. I'm an extension agent serving Hawaii's coffee industry statewide, as well as orchard crop growers in West Hawaii. Today, I'll be providing an update for UH-CTAR's coffee researchers and extension faculty, covering projects from this past year. For this presentation, I'll start off with some results of the Hawaii Coffee Industry Needs Assessment and Coffee Leaf Rust Survey, then share some information from CTAR researchers working on coffee leaf rust pesticide trials, tissue culture, and a coffee berry borer repellent and biocontrol. Next, I'll share some information from our Ag Business and Finance Extension agent about coffee efforts on Kauai, and then round out the presentation with projects taking place at the Kona Research Station. Before I begin, I wanted to take this opportunity to acknowledge and thank all of our supporters who have helped fund last year's as well as current CTAR research and outreach trials, projects, and programs. I would also like to thank our volunteers and collaborators who assist and support us during field projects and events and with information and outreach to help make an impact and address Hawaii's coffee industry needs. At the end of 2021 and through the first couple of months of this year, I asked those involved with the coffee industry for feedback on their needs and status with coffee pests and other problems. We received 128 responses, with about 91% coming from the Big Island and the remainder from Maui, Oahu, and Kauai. A majority were farm owners or farm lessees, and about 62% of the respondents farmed on 5 acres or less. 14% of the farms were certified organic, with most organic farms having under an acre of coffee. A majority of respondents were estate farmers and those who sell cherry to processors. This survey was also completely translated to Spanish. To learn more about the farms and their prospect for sustainability and profitability, a question was asked about their estimated harvested ripe cherry yield per acre. Over 60% of the farms harvested 4,000 pounds or less cherry per acre in the 2020-2021 season. A follow-up question asked how their cherry yields compared to harvest prior, and 48% said that their yields decreased a little to a lot compared to the previous 3 to 5 years. These numbers are a bit concerning, seeing that some farmers are harvesting twice the amount of cherry per acre. Observationally, I contribute this lack of production to old trees, poor fertilization practices, and damages from coffee root knot nematode. However, I could not tease out these reasons from the survey data. When farmers were asked about their main field challenges and how serious these problems were, they answered with pests and diseases, which included coffee leaf rust, coffee berry borer, black twig borer, tree decline and or death, and issues related to farm labor. While going through the data pertaining to CLR, something stuck out to me with those who estimated having under 5% CLR infection and severity versus those with much higher rates. Those with lower rates were more likely to have destroyed CLR-infected plant materials on their farm. Their farm was also less likely in need of pruning of overstory trees and surrounding plants than those with higher CLR rates. Farmers with lower CLR rates were more likely to have submitted coffee soil and or leaf tissue samples, were more likely to increase or modify the fertilization program, and more likely to have sprayed an approved fungicide to manage CLR. 20% of the farms with high CLR infection and severity did not spray any fungicides on their farm. Those with lower CLR rates continued or increase their participation in and awareness of their farm, whereas those with higher CLR decreased their farm participation and awareness or considered their time spent to be the same as years prior to CLR's arrival. When asked if farmers thought they were managing CLR at a level that kept their operation profitable, some with low CLR rates said yes, while others said they weren't sure. On the other hand, many of those with higher CLR rates did not know, and none of them indicated that they were managing their CLR at a level that would keep their farm operation profitable. When looking at what coffee-related research was requested, CLR-resistant trees and varieties, CBB, CLR and other coffee pest and disease management, organic controls, and systemic fungicides were mentioned. These next slides from CTAR Research and Extension faculty will touch up on some of these research requests in addition to what USDA ARS researchers are also conducting. The IR4 project is a federally funded program that helps specialty crop farmers with their pest control needs. Hawaii's IR4 program is a 3-person team. Dr. Chang, who is program PI, Julie Coughlin, field researcher and IR4 state liaison representative, and field researcher James Cam. A field trial was conducted in Kona in 2021 to test the efficiency of fungicide products to control coffee leaf rust. 7 products were tested: Quadris Extra, Apruvia Top, Preaxorzemium, Approach Prima, Dithane F45, Pyraziflumid, and Excalia. Fungicide products were applied to separate, replicated plots following the proposed rates, number of applications, and intervals recommended by the registrants for each product. Disease incidence and severity were evaluated before the first spray application and then subsequently approximately every 30 days for a period of 5.5 months. Coffee plots were also evaluated for crop safety and whether the product caused any damage or stunting of the trees. Plots were evaluated pre-treatment on May 3rd. There were no differences in rust incidence between treatments at this time. The first spray application was made to all treated plots on May 5th as a preventative spray when disease levels were very low in the field. Disease incidence remained below 5% in all of the treatments until late August, while rust in the untreated plots increased significantly. By September or October, rust incidence started to increase above 5% in all treated plots except Excalia and Quadris Extra. These plots had late-season applications in August, while the other plots received the last application between late May to June. Coffee leaf rust severity was low throughout the trial period. Rust severity followed the same trend as incidence. As rust incidence increased, severity also increased. No crop damage was observed in any of the fungicide treatments. In summary, all of the fungicides tested were safe to the coffee crop and provided effective control of coffee leaf rust for approximately 4 months following the first spray application. Strategic rotation of systemic fungicides with copper and biopesticides have the potential to provide season-long control of CLR in well-managed coffee farms. A sound IPM program will be essential for managing fungicide resistance. IR4 trials planned for this year include a second year of fungicide testing for CLR. Products in this trial are Pyraziflumid, Excalia, Alto, and Abound. They are also field testing fungicides for anthracnose. 2 trials are ongoing in Hawaii as well as in Puerto Rico. Field trials are planned to test the performance of herbicide GF3206, and this is a new alternative for broad-spectrum weed control with a very favorable environmental and toxicological profile. The IR4 program would like to thank Full Moon Farms and Kona Hills for their support in providing field sites in Kona. They would also like to thank Kona Extension and Research Station faculty and staff for their assistance with logistics in Kona. For more information about the IR4 project, please check out their websites. Dr. Chang has a CLR field trial with other fungicides under an SCRI grant. His trials are taking place at Kona Hills and are concurrent with the IR4 program trials. Trees used for his trials were stumped in February of this year. As new shoots emerge, they will be sprayed with a contact fungicide to protect the new growth. When the verticals are big enough, the fungicide trial is set to begin around late June or early July. These photos give a visual of what the field looked like in February after being stumped, and then in late April. Dr. Chang and his team will be testing the following products for CLR control, which includes azoxystrobin, an organic systemic product, 3 conventional systemic products, and and a bacterial biocontrol called Pseudomonas chlororhynchus. His team will collect data on the number of infected leaves per branch, the number of CLR lesions or spots per leaf, and percentage of leaf surface infected by CLR. Coffee leaf rust incidence and severity will be evaluated along with any phytotoxic effects from the fungicides. Dr. Michael Shintaku is researching micropropagative techniques for CLR-resistant coffee under an SCRI grant. Goals of his project include establishing coffee in vitro in preparation for large-scale micropropagation, setting up a bioreactor facility to increase the number of plantlets, and then producing CLR-resistant clones and acclimatizing these plants for ex vitro propagation. Dr. Shintaku's team currently have several coffee varieties in culture from leaf materials taken from CLR-resistant trees. The photos on the left show embryonic callus developing on these leaf explants that were put into culture on February 24th of this year. This is just step 3 of 11 or so in a process that can take about 2 years in total for plants to emerge from the nursery. However, these are important steps towards reproducing CLR-resistant plants that can then be distributed en masse to the entire industry. Dr. Mark Wright, who is an entomologist in CTAR's PEPS department, continues to work on a CBB repellent and biocontrol agent. Dr. Wright's team have tested a pine beetle repellent pheromone called verbenone for a few years at Waialua State Coffee and used a splat delivery system which slowly emits the active ingredient at a controlled rate for a couple of weeks up to 6 months. Preliminary trials showed that it repelled CBB and had the potential to reduce infestation by 50% with a push-pull strategy that included the use of CBB traps. Dr. Wright was issued a Hawaii Department of Agriculture experimental use permit to continue this research. This year, flowering was late on Oahu, but trials will begin soon, and they are hopeful to have this verbenone product registered towards the end of this coffee season. Other research with Dr. Peter Follett of USDA PBARC includes Phimastachys coffea, a CBB biocontrol agent. This tiny parasitic wasp originates from Africa and is found throughout Latin America. The short-lived Phimastachys female lays 2 eggs per CBB adult, and its progeny emerges from the beetle as shown in the photo. This wasp is very host-specific and is not known to attack any Hawaiian native beetle species. Applications to release Phimastachys in Hawaii is under review, but researchers are hopeful for a positive response later this year. Now, jumping into CTAR's extension agents. Shannon Sand is an assistant extension agent in agricultural business and finance. She wanted to share a little bit about inflation in the U.S. and how it affects Hawaii's coffee producers. The graph shows that in the past 12 months, inflation has been increasing among major categories, including food, non-food items, and energy. Energy has had the greatest increase of about 32%. Overall, March 2022 inflation reached 8.5%, which has been the highest rate of inflation in 40 years, and this has caused major changes in purchasing power by customers. This graph provided by the U.S. Bureau of Labor Statistics shows an increasing trend among the Producer Price Index for roasted coffee in the U.S. This family of indexes measures the average change over time in prices received by producers for domestically produced goods, services, and construction. According to this graph, U.S. coffee producers are receiving some of the highest prices for roasted coffee in the last 50 years. PPIs measure price change from the perspective of the seller. This contrasts with other measures such as the Consumer Price Index, which measures price change from the purchaser's perspective. So what does this mean for Hawaii coffee producers? Likely it means an increase in input prices, which most are probably already aware of and affected by. What can producers do? Producers should review their budgets and farm records to better understand their options to minimizing costs while maximizing revenue and profits. They can compare their farm to benchmarks set by high-quality, high-yielding, sustainable, and profitable farms. Producers can attempt to decrease input costs where possible and in ways that product quality is not jeopardized. and they can consider adding value to their product to increase revenue and profitability. Dr. Roshan Manandar is an assistant extension agent for invasive species management. He is located on Kauai and has been working with the Hawaii Department of Agriculture and the Kauai Invasive Species Committee to survey for CBB in coffee at farms, which include Moloa'a Bay Coffee Farm. They are conducting visual surveys as well as inspection of CBB traps and have found that visual surveys are easier and faster to conduct than monitoring traps. Dr. Manandar is also working with Dr. Kunhui Wang of CITAR to survey for coffee root knot nematode on Kauai. So far, coffee root knot nematode has not been detected on commercial farms on the island. He continues to coordinate CBB and CLR response planning monthly meetings between CITAR, HDOA, and KISC. Roshan and I have also worked with KISC to create CBB and CLR rack cards shown on the left, which is aimed at educating backyard coffee growers and the general public. Here in Kona, myself, Matt, and Nick are conducting outreach and maintaining coffee projects in germplasm, including a small plot of Catamore mocha hybrids that are resistant to coffee leaf rust. I harvested cherry from 18 of 20 individual trees from 10 different selections of Catamore mocha hybrids, Sarchimore hybrids, and T8667 Costa Rica 95 hybrids that are CLR resistant. I harvested every 2 weeks, weighed and hand pulped the cherry, fermented, sun-dried, and vacuum sealed the parchment from each harvest between September 2021 and January of this year. On March 15 of this year, Tommy Greenwell of Greenwell Farms hosted a cupping of 4 of these Catamore mocha hybrids. The Q-grade cuppers included Chai and Jennifer of Greenwell Farms, Brittany and Madeline of Pacific Coffee Research, and Dr. Tracy Matsumoto of USDA PBARC. I'm additionally grateful to Tommy and Chai, who hulled, sorted, and roasted the coffee for the cupping. Chai also helped to collate the results and coffee descriptors from the cuppers' score sheets. These 4 hybrids were selected for their overall yield, cherry size, and parchment quality. The cupping also included Kona Typica from the past season's crop. These Catamore mocha and Costa Rica 95 hybrids were genotyped by Dr. Dapeng Zhang, a USDA ARS research geneticist in Beltsville, Maryland. Compared to Kona Typica, trees 2, 4, and 6 are dwarf with green leaf tips, and tree 15 is dwarf with dark bronze leaf tips. When compared to an average cherry weight of coffee from grafted Typica trees grown at the Kona Research Station, these selected hybrids had cherry that, on average, weighed nearly as much or more than Typica cherries from the station. In addition, these trees had heavy to relatively high yield from a single bearing vertical. Most exciting were the cup scores from the March 15th cupping, which exceeded the minimum of an 80-point score for specialty coffee. All 3 Catamore mocha hybrids scored higher than the Kona Typica on the table, and tree 4 had the highest average score of 84 points. Descriptors of tree 4's cup profile are listed below the table. This season, I plan to monitor these trees for continued CLR resistance and again harvest cherry from the individual trees to confirm cherry and cup quality. Not all trees produced cherry last season, and some did not produce enough cherry to determine average berry size and tree yield. So we will see if these trees should also be considered for cupping analyses. We are currently working to replicate the top producing high quality trees in this field. In my attempts to replicate the Catamore mocha hybrids, I'm trialing different methods of grafting onto Liberica rootstock to improve my grafting success rate. So far, I've found that by grafting vertical suckers from the stump, I can graft onto younger Fukunaga and Arnoldiana rootstock seedlings because the scion diameter is smaller than tips from older verticals. I have had success using a splice graft, which is one of the simplest methods of grafting. I use parafilm to wrap the scion and electrical tape to fuse the rootstock and scion together. I've found that by retaining 2 or more leaves on the rootstock, this also improves my grafting success. A mist chamber is not necessary if wrapping the entire scion with parafilm. However, if young leaves are exposed at the scion tip, a humidity chamber will help to reduce scion wilting and death due to water loss via the exposed leaves. Once the graft union is healed, the parafilm and tape is carefully removed to prevent any type of growth restriction and to deter pests and disease issues. This year, I'll also try similar grafting techniques on recently stumped trees in the field. In addition to the CBB videos, this year, Stuart, Shannon, Matt, and I have added recorded presentations to the Kona Extension YouTube account, which includes the topics of crop insurance, USDA disaster assistance programs, coffee leaf rust monitoring and management, various pesticide products, and worker protection standards. We welcome you to visit our Kona Extension YouTube account and to watch the posted videos. Next Tuesday, Ariana Wood will be presenting on a ProBlad Verde field trial which was conducted at the Kona Research Station last year. Please register and join us on Zoom for her pre-recorded presentation and a live Q&A session on May 24th. Also, Roseanne Liner is co-hosting the final 2 Talk Story sessions with CBB and CLR researchers on May 26th and June 2nd. Please register and join us online for these presentations as well. Save the date for our coffee desuckering field day on June 4th at the Kona Research Station. In the future, I plan on hosting other events such as those listed to address requests from event evaluations and the coffee industry survey and to fulfill grant obligations. Those of you who joined us for WPS and sprayer calibration field days, you may recognize Extension agents Jensen Ueda from Oahu and Rosemary Gutierrez Corright from Maui. Both agents have been an integral part of last year's projects as well as current outreach efforts, and we look forward to having Rosemary once again joining us for events translated in Spanish. I encourage you to visit my hawaiicoffeeed.com website for up-to-date information on various coffee pests and problems, CBB and CLR information, ag announcements, and other coffee-related topics. If you hover your cursor over the Coffee Leaf Rust tab, you'll find sub-tabs on CLR photos, sanitation, serving and monitoring, spraying and pruning, the HDOA pesticide subsidy program, and Bovaria compatibility. If you click on the Spraying for CLR tab, you'll find translated materials and pesticide use information, along with details and tools for sprayer calibration and pesticide calculations. If you have any questions about the projects or events mentioned, please don't hesitate to contact us. Thank you for this opportunity to share the work by CTAR's researchers, extension agents, staff, and collaborators.